Hi, under the course 19 MA 206 Logic and Combinatorics, we are in lecture number 3 for Unit 1 Sets and Functions. So already we had seen lecture 1 and lecture 2 where in lecture 1 we had seen what is the relation, what is the range, what is the domain, what is the codomain, what are equivalence relations, what are composition of functions, and how do I, in the second lecture we had seen few problems, how to find the inverse of a functions, how to find the composition of functions when three functions are given, etc. Now we are into the third lecture. So let's start the presentation. So again, I repeat the course outcome for this particular unit 1 sets and functions. Construct the class of functions which transform a finite set into another finite set which relates to input and output functions in computer science. So in this presentation, we insist on equivalence relation. So we know what is sets, you know what is a relation. What are equivalence relations? A relation is said to be equivalence if and only if there are three conditions. That is, one is the reflexive, transitive, and symmetric. So only if three conditions are satisfied, we can call a relation as equivalence relation. So problem number 1, prove that capital R is equal to A comma B, the set of K A comma B, such that A plus 1 plus AB, which is greater than 0, on capital S is transitive or not, where S be the set of all real numbers. So solution. So first I start with capital R is equal to A comma B, such that A 1 plus AB is greater than 0, since A comma B belongs to this capital R. Now B comma A belongs to capital R because 1 plus AB is greater than 0. So it is symmetric. So symmetric is AB should be equal to BA, like that. So it is symmetric, and also A comma A belongs to capital R, 1 plus A, which is greater than A. So it is reflexive. So symmetric will be AB, two elements at a time, AB, BA. Whereas reflexive taking the same elements at a time, AA or BB or whatever it may be. Transistor will be taking three elements at a time. So transistor, we find 2, 1 by 2, which belongs to capital R, and 1 by 2, minus 2, which belongs to capital R. So one term I'm taking as 2, 1 by 2, and the other term I'm taking as 1 by 2, minus 2. So, but when I say 2, minus 2, does this belongs to capital R? It does not belongs to capital R. Why? Since 1 plus 2 of minus 2. So, you take this plus 2 as positive 2 as A and negative 2 as B. So, I'll be getting 1 plus 2 of minus 2 will be getting 1 minus 4, which is minus 3, which is not positive. Therefore, R is not transistor. Hence, R is reflexive, symmetric, but not transistor. So, two conditions are satisfied, but one is not satisfied. But we cannot call here R as equivalence relation. Problem number 2. Let capital A is equal to R difference of set 3 and B is equal to R difference of set 1, which means that 3 is exempted and here 1 is exempted, that particular R. Consider the function f from A to B defined by f of x is equal to x minus 3 by x minus 2. Show that f is 1 to 1 and on to, and hence find f inverse. So we've already seen what is f 1 to 1 and on to functions in lecture number 1. 1 to 1 is also called as and you know the other names also. So first A is equal to R of R difference of 3 and B is equal to R difference of 1, and f is a function which is defined from the set A to set B. So what is f of x? It's given as x minus 2 upon x minus 3. So we know that f of x1 is equal to f of x2. So x1 minus x2 divided by x1 minus 3 is equal to x2 minus 2 upon x2 minus 3. So cross multiplying, x2 minus 3 into x1 minus 2 is equal to x2 minus 2 into x1 minus 3. So simplifying, just multiplying, just open up brackets, you get your derivation as x1 is equal to x2, which is when f of x1 is equal to f of x2, it implies x1 is equal to x2, which is the condition for 1 to 1. So it is proved. On to. Okay. So now what we do? So therefore f of x is 1 to 1. So f of x is equal to x minus 2 by x minus 3. So replacing this f of x is also called as y, right? So y is equal to x minus 2 by x minus 3. So cross multiplying y into x minus 3 is equal to x minus 2. So yx minus 3y is equal to x minus 2. So yx minus x, bringing this, grouping this x together and y together, and I'm getting the value for x. X is equal to 3y minus 2 divided by y minus x. So f of x is equal to x minus 2 by x minus 3. Now replacing that function, wherever x comes, replacing in the place of f of x, that value, simplifying, I get it as f of x is also equal to y, therefore f of x is onto. So therefore f of x is bijective and invertible. And now f of x is equal to this function and y is equal to y is replaced like that. And this is invertible, means what you're going to do, replacing all your x as y and y as x. So x is equal to y minus 2 and y minus 3. So this y is replaced as x and this x is replaced by y. So cross multiplying, simplifying, you get your y, and this y will be called as f inverse of x. Okay, this is invertible. So invertible means replacing x as y. Thank you.